So, good evening, everyone. We can wait another 2-3 minutes. After that, we can start. Okay, I think we can start. Let me share my screen. Okay. Okay. I think my screen is visible to everyone, so we can start slowly. Okay. So in meantime, whoever will join, so they can join automatically. So good evening all. Myself Swankar from Indian Institute of Science. So I am doing research in electrochemistry, basically energy storage system. So this is a electrochemical technology in pollution control on an NPTEL online certificate course. So what we have learned earlier, so this is the summary of the thing. So this is the content of this course. We already completed up to this properties of solution and the properties of solution in 2 class, but the last class we have learned so many things about the conductivity and solution properties. So today we'll discuss some of the electrochemical basis of titration. So I will not it is called discuss again whatever professor have taught. So some of the problems I will discuss. Okay, before going that, what we have discussed previous class, so that thing I can summarize. So in the previous class, okay, what we have discussed the electrogravimetry, where basically you are depositing something on the electrode surface and you are taking the weight before the deposit and after the deposit, and how much deposition is happening. So that thing we can get from the electrogravimetric. So that thing we have learned. Second thing we have learned some of the conductance, specific conductance and cell constants. So we know that R is equal to rho by L. This L by A, that is called cell constant. So how to calculate cell constant, that also we have discussed. Some standard solution you have to take, like different concentration of KCl, and from there you will get to know how, what is the specific conductance for different concentration of KCl, and from there you get the cell constant. If you know once the cell constant, then you can calculate what is the conductivity of your solution or unknown solution. So that we have discussed last week. Then we have discussed the conductivity graph of weak and strong electrolyte, where we see that in the case of a strong electrolyte, when we are dilute the solution, the conductivity is linearly increasing like this. And in the case of weak electrolyte, initially it is increasing, and when it is conductivity, so when the dilution concentration is very low, the conductivity of the weak electrolyte is suddenly increasing due to the dissociation of the electrolyte. Okay, so that things we have discussed. Then fourth, what we have discussed, the solubility product calculation from the conductivity data, and then degree of dissociation and different type of conductimetric titration, like redox process or precipitation, different weak, strong, weak electrolyte. So different type of electrolyte we have discussed. And after that we have discussed galvanic cell, where basically you are transforming the chemical energy to electrical energy, and electrolytic cell where the opposite process or happening compared to galvanic cell. And then we have discussed the electrical double layer, where we have seen that near the electrode surface, where opposite charge is compactly situated near the electrode surface, where in the when you are going far from the electrode surface, there is a positive and negative charge are equally distributed. Okay, and then after that we have discussed Nernst equation, where E is equal to E naught plus RT by NF ln oxidation by reduction concentration. So these things we have discussed, where this E naught is the standard potential. And this E basically E cell, whatever we are measuring from the cell. Okay, and the polarization and over voltage, where suppose some thermodynamic process is happening, some potential, that is E1, and but when you are doing the experiment and that is going happening in the E2, so the difference between E1 and E2, that is called the over voltage. So these things we have discussed. So now we will discuss some of the assignment question in the previous year. So along with that, I have added some extra question, which is more important to understand the topic whatever we have learned in the in this week. Okay, so let's start with this problem. So the problem number 1 is calculate the standard cell potential of a voltaic cell that uses the AgAg plus and SN2 plus half cell reaction. So it is given the anode reaction. This is where the anode reaction, where the oxidation happening. So this is a 2 electron process. SN2 plus is going to SN is going to SN2 plus 10s, and the cathode where the reduction is happening. So this is oxidation and this is reduction. So it is given that so what is the standard potential of the cell. Okay, so can anyone tell what is the standard potential? It is given the hint. So I think this will be like this, not so it is in the subscript. Okay, so it is given. So hint is given that you have to what is called, use this cell. So E cell is standard, that is E redox minus E oxidation. Okay, so I have written this E oxidation and E reduction. So what will be the answer? There is 4 options. First option is positive value 0.55 volt. Second one is 0.94 volt. Third one is 0.88 volt. D, that is 0.1 volt. Which one will be the answer? If people can write in the chat box also. Or you can unmute and then tell. Yes. Zero 0.94 volt. Okay. Okay, so until the 0.94 volt. So we can do this thing. So I have written this is the reduction and this is the oxidation. So the oxidation, which one is oxidation is happening? So we have to write the reduction potential. So I want to mention here, when you are writing these things, so E oxidation and E reduction, that is the reduction potential. Means suppose this is E naught of Sn2 plus is going to Sn, that is 0 plus 0.8 volt, and E naught Ag plus is going to Ag, that is minus 0.14 volt. Okay, so we have to put this value here. Okay, suppose means if you change, this is reduction potential of Ag plus to Ag. If you write the oxidation potential of Ag plus to Ag, that will be plus 0.14 volt. Okay, so always in the equation you have to put this reduction potential. Okay, so then you can write this thing 0.8 minus 0.14 volt. So 0.8 plus 0.14 volt, that is 0.94 volt. Yeah, so B is the answer. Yeah, correct. So the second question is, so in our college, Deepak is doing potentiometric titration of unknown concentration of silver nitrate solution with respect to a saturated calomel electrode, reference electrode. In one container contain in X molar of silver nitrate and other container contains silver nitrate which is directly connected with salt bridge. So these two container we have, and both container, one container has silver nitrate, another container has silver ammonium nitrate, and which are connected by salt bridge. Now, when the silver wire dipped in the corresponding solution, the potential of the solution is 0.4 volt. That is not solution, that will be cell. Okay. So can you tell how much silver salt concentration the get potentiometric titration? So it is given ESC, I think that will be ESC, calomel electrode reference, that is given. in the voltage. Okay, so how you can see this problem, how we can solve? So I think in the class we have seen that one container, two container is there. One container, it is ammonium nitrate is there, which is ammonium plus and nitrate minus. Other one, silver nitrate is there. Okay, and this silver nitrate and ammonium nitrate are connected by salt bridge. So what is salt bridge? Salt bridge is basically in agar-agar gelatin, and in the salt bridge NH4 plus and NO3 minus is to there. So it is telling that one side, this is calomel electrode is there, other side this is silver wire, it's dipped. Okay, so when they dip, they calculate the potential. So that one, it is showing that E cell 0.4 volt. Okay, now question, what is the concentration of silver nitrate solution in the cell? Okay, so how we can proceed this thing? So we know what is the Nernst equation. Nernst equation for Ag plus. So Ag, that E cell is equal to E naught of Ag plus RT by NF ln of Ag plus concentration by Ag concentration. But as this is the solid, so we can take this is the 1. Okay, so then how we can proceed? Then Ag is equal to Ag naught plus RT by NF ln of Ag plus. So this thing you can write as a 1. Okay. And another thing what we know, E cell, as it is measuring with respect to AC, so E cell what we can write? E cell is equal to E of Ag minus E of saturated calomel electrode. Now this EAg, we can replace this one. E cell is equal to E naught of Ag plus RT by NF ln of Ag plus minus E of SCE. Because we have to calculate the Ag plus concentration. Then we can get the what is the concentration of silver nitrate. Okay. So this equation how I can write? So we can keep this one as the left side and all these things we can take in the right side. So what I can write? So RT by NF ln of Ag plus, that is equal to E cell minus E naught of Ag plus E saturated calomel electrode. So this E cell value it is given. Okay, sorry. Now E cell or ln of Ag plus, that is E cell minus E naught of Ag plus E saturated calomel electrode divided by RT by NF. So there is nothing is mentioned the temperature, so we can take as a room temperature, that is 298 Kelvin. Okay, and this R value, that is standard 8.013 into 10. 8.013 kilojoule, no, mole Kelvin mole inverse joule. And T temperature and A is the Faraday constant, that is 96500. Okay, Coulomb. So this thing you can write Ag plus. So initial it is given 0.4 volt minus what is the standard potential of Ag? So that is minus 0.9799, and this is calorimeter electro 0.246. 246 divided as it is room temperature, so we can write this one as 0.059, and Ag is going to Ag plus is going to Ag, so that is n is equal to 1. So you can write 1. Okay, so this is the thing. Now we can calculate this one. Anyone can calculate how much it is coming? Ag plus, I think I can also calculate 0.4 minus 0.799 plus 0.246. Okay. So this is minus 0.153 divided by 0.059. So that is minus 2.593. Okay. Now Ag plus, if you see, anti-lockup. .593, so it will be around 2.53 into 10 to the minus 10 to the minus 3 molar. Okay, so this is the answer. Okay, so we can go to the next problem. So it is the next problem is a cell of platinum electrode dipping in 0.1 normal ferrous sulfate. So this problem is clear, no? So if anyone did not get any point, so they can tell. So I can explain again. So this is third problem. So a cell of platinum electrode dipping in 0.1 normal ferrous sulfate with respect with a saturated caramel electrode as a counter cum reference electrode. A potential difference is 0.395 volt is obtained. How much percentage of iron 2 which has been converted to iron 3 by oxidation? Okay, so basically means in the solution you have iron 2 plus which is converting iron 3 plus electron in the presence of platinum oil. So the cell potential is given 0.5. So it is telling that how much percentage means basically it is asking Fe3 plus, because if you write Fe3 plus and Fe2 plus, so this percentage of these things they are asking. So it is quite easy. Whatever in the similar way, whatever we have done in the earlier, so that similar way we have to do. Okay, so this is a Nernst equation you can write. What is Nernst equation? E cell is equal to E naught cell plus RT by NA So whenever there is no mention of temperature or something, so we have to take as a room temperature. Okay, so Ln Fe3 plus oxidized form by reduced form. So what are the things they have given? So this is basically Fe3 plus Fe2 plus. Okay. So this is the equation. Now we know E cell as it is the reference electrode saturated caramel electrode. So E cell we can write E cell is equal to E Fe3 plus Fe2 plus minus E saturated caramel electrode. So same way we can get. So if you bring this one is left side, so this one we can write E naught Fe3 plus Fe2 plus RT by NF ln Fe3 plus divided by Fe2 plus minus E. Okay. Now I can keep this part. Another thing I can bring this side. So as it is room temperature, so we can write this one as a this RT by NF as a 0.059 log of. So this thing we can write 0.059 as it is one electron process log of Fe3 plus by Fe2 plus, but it will be E cell minus E naught of Fe3 plus by Fe2 plus E of saturated caramel electrode. Okay. So what will be 0.059 log of so E cell how much they have given 0.395 and what is the standard potential 0.77 plus 0. Saturated caramel electrode how much it is given here 0.246 okay so this much. So if you calculate this thing Fe3 plus Fe2 plus how much you will get you can calculate once. If people can also calculate with me. So 0.395 246 divided 0.059. So it is coming around 6.3 into 10 to the minus 3. So if you want to percentage, so you have to multiply by. So you have to multiply by 100. So here you can multiply by 100. So that will be 0.63%. Okay. So this is clear. Okay. Now we can go to next problems. It is given calculate the cell potential for a electrochemical cell palladium 2 plus cadmium which is going palladium plus cadmium 2 plus. So what is given the cell E naught set potential it is given, temperature is given that is room temperature and cadmium concentration and palladium concentration also given. So what is the cell potential we have to calculate. Okay. So what is given, the hints it is given, then use Nernst equation for the cell at 298 Kelvin. Okay, so Varun has written 0.306 volt. Oh, okay. Yeah, so we can check once. So it is written Varun. You can check Varun answer is correct or not. So basically here what is happening? So Pd2 plus, it is cadmium 2 plus. So P palladium plus cadmium 2 plus. So this one is happening what? Oxidation. And this one is happening reduction. So Nernst equation, what we know? E is equal to E cell plus RT by NF ln ox by rate. Okay. So E is equal to E cell, as this is 25 degrees Celsius. So T is equal to 295, 98 Kelvin. Okay. So what you can write? 0.059. This is 2 electron process. So by n is equal to 2 log of. So which one is oxidizing? So cadmium. So cadmium 2 plus concentration divided by which is reducing? Palladium. So palladium 2 plus. Okay. So all the things it is given. So E naught, that is E naught. So E naught it is given 0.277 plus 0.059 by 2 log of 0.2 by 0.2. Okay. So 0.277. This one we can write this 0.2. So you people can calculate once. I think Barun already is quite fast. Okay. Yeah, I think Barun is correct. It is coming this. Okay, so we can go to the next problem. So next problem is in the standard notation for a voltaic cell, the double vertical. So this one represent what? So it is a phase boundary, or it is a gas electrode, or it is a wire or metal connection, or a salt bridge. So which one will be the answer? So when there is some redox reaction, we is to present that redox reaction in cell, what is called, in cell presentation. So if you see in the previous one, so this one if you write in the cell presentation, question, what is a palladium 2 plus cadmium, it is going Pb plus cadmium 2 plus. So this is the reaction. So what cell presentation, what we can write? So the left side it will be oxidation. So what is happening oxidation? So cadmium 2 plus, that is aqueous, cadmium, that is solid. We can write like this, and then it this side, right side, it will be reduction. What is reduction? Palladium 2 plus, that is in aqueous palladium. PV. So these things, so basically this one, these things representing, these are the in the same phase or same container. This one also same phase. So this is representing the salt bridge, which are connected. So okay, Varun has written. So D is the correct answer. Okay. So the question number 6, a pH meter is an example of an ion selective electrode, a fuel cell, a reference electrode, and electrolytic cell. So which one will be the answer? A ion selective electrode. So if you see, so this is the picture of a glass electrode. So where you can see this is the reference electrode part, where the reference electrode body is there, and in middle there is the internal electrode. So here is the glass membrane is there, where some selective ion can passes. Okay, so this A is the answer. Other things is this glass electrode also what is called to measure the pH of the pH of the solution. So here the reference electrode is there in between this inside this electrode. So that means the reference electrode we cannot use because there is the reference electrode inside the cell. Okay. So we can go to the next problem. So which of the following compounds is the best conductor of electric current? One is option A is acetic acid solution, option B hydrochloric acid solution, option C ammonia, option D glucose. Yeah, one written hydrochloric acid solution. Why a hydrochloric acid? Why hydrochloric acid, not acetic acid or ammonia or glucose solution? Can anyone tell?
Mobility of H plus ions will be more.
Okay, mobility in acetic acid also H plus ion is there. Is it not? Acetic acid, CH3.
Acetic acid is a weak acid which partially dissociates.
Yeah, acetic acid. So if you see CH3, C double O minus plus H plus, and HCl if you see, so it will be H plus plus Cl minus. So both case H plus is there. Yeah, acetic acid is weak acid. So if you see ammonium solution means ammonium hydroxide. So NH4 plus plus OH minus. Okay, so this thing I think we have discussed in the last class. So because this one and this one, this is weak electrolyte. This is also weak electrolyte. This is weak base. I can write weak base. So but in HCl, H plus it's hydrochloric acid that is fully dissociate, and we know that mobility of H plus is more compared to OH minus or Cl minus. That means H plus ion conductivity is more. Okay, and other thing HCl is fully dissociate, so the number of ions in HCl is high. So for this, hydrochloric acid has a higher conductivity. So that's why the best conductor in this 4 option is hydrochloric acid. Okay. So we can go to next question. If a current of 0.5 ampere flows through a metallic wire for 2 hours, then how many electrons would flow through the wires? So there is 4 options. So how we can proceed with this problem? Can anyone suggest how we can proceed? So what are the things it is given? Current value it is given. And what are the things? Time is given. Then electron number we have to calculate. Okay. So as current is given, so sorry. So I is given, I is 0.5 ampere. Time is given 2 hours. Okay. So what we know? What is the charge? How we can calculate charge from this parameter? Can anyone tell? Okay. Anil is telling D. Okay, Anil, can you tell how we can calculate charge from the current and time? What do we know? Current is equal to charge divided by time. That means Q divided by T. So in this T we can transfer to second. So these 2 hours is 3600 into 2, 72 seconds. Okay. So here you can write Q is equal to, this is I. So I into T. What it will be? 0.5 into, what is the time? 7200. The coulomb. So this we know. Now what is Faraday's law we know? Law. What it is to tell? That 1 Faraday, what is the definition of 1 Faraday? Can anyone tell? What is the definition of 1 Faraday? Is the definition? 1 Faraday, that is 16500 coulomb. So if this much of charge if we transfer, then one equivalent of that compound will be deposited. 816 coulomb of charge will transfer to any compound, then 1 gram equivalent of that compound will deposited. So 1 gram equivalent means 6 into 625 into 10 to the 23 number of, that is Avogadro number, Na. 6.623, I think. Yeah, 623 into 10 to the 23 number of atom. Okay, so if it is a 1 electron process, then 6.623 into 10 to the 23 number of electron. Okay, so if you transfer this much of charge, then this much number of electron will pass through the wire. Okay, then we can calculate now how much for this it will be transferred. So this much 96500, if you transfer, then 6.623 into 10 to the power 23, then 3600 coulomb. If you transfer, then how it will be? I can write here 6.623 10 to the power 23 divided by 96500 into 3600. Okay, so you can calculate how much it is coming. Can anyone tell how much it is coming?
Point 247 into 10 raised to 23.
How much? 1 point. I can take another color. 623 into 36 divided by 0.65. Okay. Yeah, mine is coming 2.4246 into 10 to the power 22. This one is coming. Someone is written C. Yeah, I think C is the answer. Anil, you can check once your calculation. I think you have done something mistake. You can once cross check. I think C is the answer. Okay. So we can go to the next problem. Anil, you can check once. Okay. So the next question is 45 gram of ethylene glycol is mixed with 600 gram of water. Calculate the freezing point of a solution. Okay, given the molar freezing point depression constant for water is 1.86 Kelvin kg per mole. So they have given the hint. So use the molarity formula and this formula. Okay, so they have given two options. So, oh, sorry. So anyone can tell what we know depression of freezing point? Molar depression of freezing point. Del TF, that is proportional to molality of the solute. That we know, no? I think last class or last to last class we have learned this thing. So del TF, that is equal to, if you, that is Ka. So this is the depression, molar depression constant. So this value they have given 1.86 Kelvin kg per mole. So what is molality? So they have written use molality formula. What is molality? Can anyone tell? What is molality? Something is there, no? Like this. In the below, weight of solvent in kg, and in the molar equivalent weight of solute.
Solute.
Yeah. So now we can calculate this thing. So this C2H6O2. So what is the molecular weight? Carbon is 12 into 2 plus hydrogen 1 into 6 plus oxygen. What is the molecular weight of oxygen? 16. So how much it is coming? How much it is coming? 24 plus 6 plus 32. So
62.
24, 62. Okay. Then it is given that 45 gram we have dissolved. So then N is equal to 45 divided by 62. Okay. How much it will be? 45 divided
0.72. 0.72.
0.72. Okay, this is the mode. So you can write here, and 600 gram, the 1000, that will be 0.6 kg. That is the weight of the solvent. So you can write this thing 0.72 divided by 0.6. So how much it will be?
1.2.
1.2. Okay. Now we can put this one here. So del TF, that is TF naught minus TF is equal to K 1.86 into 1.2. So what is the TF naught? So that is in what is called pure water. What is the freezing point? 0°C, no? Freezing point. So there 0°C means 273 Kelvin. So 273 minus TA is equal to, this one you can calculate, 1.86. That is 2.25. So TF is equal to 273 minus 2.25. So it is coming to 70.75. Okay. So what it is given 9.5. So it is 7.5 maybe it will be. So close to this. D is the answer. Okay. So this way you can proceed this type of problem. Okay, next problem is hydrogen atoms emit several sets of various frequency radiation. They can be grouped in to how many of the following series? I think this one we have discussed in the first class in the atomic structure chapter. Okay, so which one it will be? Lyman-Balmer only, Lyman-Balmer bracket only, Lyman-Balmer Pfund only, Lyman-Balmer patient bracket Pfund. So which one will be the answer? Yeah, answer D. Yeah. So I can just summarize whatever we have discussed earlier. I think this is the slide we have discussed earlier, this one. So basically Lyman series, when from the higher orbital to n is equal to 1 it is coming, that is called Lyman series. So and when n is equal to 2 from the higher orbital 3, 4, 5 it is coming, that is called Balmer series. So there are also different type of part is there, so that is called alpha, beta, gamma, that also there. Okay, so in this which one is the which spectrum region? So this Lyman is UVB region, and this Balmer series is visible region, and all other in IR region. So these things we have discussed, and from their Rydberg constant also we have discussed constant R. Okay, so to calculate Rydberg constant, I think we have discussed 1-2 problem also. Okay, so the answer is D. Okay, so next question is, which of the following is not a type of electroanalytical technique? I think last class we have discussed potentiometry, voltammetry, coulometry, gravimetry. Which one? Electroanalytical technique means electron. Electroanalytical technique. What is electroanalytical technique? So basically you are transferring the electron, and due to the electron transfer, whatever changes is happening, and that changes, from that changes you are getting the information. Okay, getting the information. So that is the thing. So if you see potentiometry, so here we are measuring the potential voltage. So that means when you are transferring the electron, so that from there you are getting the voltage. So that voltage you are measuring with respect to a reference electrode. So that means this potentiometry or voltammetry, so that is we are getting the potential due to the transfer of electrons. So this is also potentiometric technique, and this voltammetry also potentiometric technique. Coulometry, basically you are measuring the charge. Okay, so that is also electroanalytical technique. But gravimetry, where we are measuring weight, means this is weighing balance we know. So that in the weighing balance, where we are putting the what is called weight, and you are getting the weight of the sample. So in there you are not externally, you are not putting any electron or something. Okay, so that means the gravimetry, which is not a electroanalytical technique. Okay, so we have discussed electrogravimetry. I think electrogravimetry. Okay, so but it is only the gravimetry. So if it is electrogravimetry, then what is called, you are transferring the electron, and some compound are depositing on the on your electrode surface, and then you are measuring the weight. And that weight, so due to the electron transfer you are depositing. So for this, that is a electroanalytical technique. But only the gravimetry, that is not electroanalytical technique. Okay. So next question we can tell, among the quantitative methods of analysis for polarography, standard addition method is suitable because it accounts for dilution effect, matrix effect, either dilution or matrix, none of these. I think last class also we have discussed this thing. Which one it will be? Hmm? Polarography. Polarography, what we are, I think this is not detailed discussed in this week. So maybe next week we'll discuss more. But just I am telling. So they are polarography, basically they are dropping mercury electrode is there, control growth CGME. So control growth mercury effect. So what is there? So here you have the analyte and one capillary is there where the mercury is there. Okay. And another mercury electrode which is acting as a what is called counter or reference electrode, and this is working electrode, and you are measuring the what is called potential, and this dropping, when the dropping electrode is formed and it will come out from the capillary, again new drop of mercury is forming. Okay, so that when you are adding the mercury step by step, that means the solution what is called volume of the solution is increasing, so that you are diluting the electrolyte. So dilution effect is one answer. Yeah, I think O'Neill has written dilution effect. Yeah, that is correct. Okay, and other one also matrix effect. I think last class I have discussed more what is the matrix effect, all these things. Okay, so we can go to the next problem. So the question 13, the half cell reaction of cathode in the cell cadmium to cadmium chloride and silver. This is the cell representation. Okay, so may be written in either two ways. So Ag is going AgCl is going Ag. The standard potential it is given, and second is given that Ag is going to Ag solid. So that is also given. Okay, so write the complete cell reaction with both alternatives and show that they predict the same value for the cell EMF. So it is given this thing. So there is a two reaction. One reaction is cadmium silver chloride is going silver. So both cases silver solid is forming. And other is silver, some other aqueous salt is there and it is going silver. So both cases standard potential is given. So they are telling that in both cases you calculate the EMF value and you tell that this process whatever, so that is same value it is giving or not. So that is the question. Okay, so how we can the same value of EMF or cell potential. So how you can proceed with this? Can anyone tell? So the cell reaction it is given here. So I can write this cell reaction. Okay, then it will be easy. Okay, so one I can write what is the anode in this cell. What is the anode reaction? Suppose I can write anode. Anode reaction. What is happening? Where the oxidation is to happen. So cadmium, it is going to cadmium 2 plus. Okay, so it is given E naught. So plus at this is 2 electron process. Okay, so E naught, I can write E naught minus 0.402 volt. It is given here. Okay, and what is cathode reaction? AgCl solid plus 2 electron. So this is not what it will be. 2Ag solid plus 2 chlorine minus aqueous. So this potential it is given here. So E naught is equal to 0.222 volt. Okay. Then if you combine these two cells, then what it will be in cell? I think this way we used to do in the BSc type. So cadmium solid plus 2 AgCl solid, which equilibrium cadmium 2 plus aqueous plus 2 Ag solid plus 2 chlorine minus aqueous. So you can these things you can write how much it will be. So this is anode reaction and this is cathode reaction. So this thing we can write in this way. So E cell, that is E cathode minus E anode. So what is E cathode? 0.222 minus 0.402. How much it will be? 0.624 volt. Okay. All people are getting what I am doing. So whatever means potential or reaction is given, that things I am writing. Nothing extra thing I am writing. Okay. So this is one reaction, this thing. Now we have to write the second one. Okay. So second one is the anode reaction is same, but the cathode reaction is different. Okay. Second one I can write in the next slide maybe. The second one is, what is the anode? Anode reaction is same, where cadmium is going to cadmium 2 plus 2 electron. Again I can write same thing, minus 0.402 volt. And but the cathode reaction this time, what is their cathode reaction? Ag plus aqueous is going to AgCl. Aqueous is going to Ag solid. So E naught it is given 0.799 volt. Now we can write what is the cell reaction. Cadmium, that is solid, plus 2Ag plus, that is aqueous, which is going to cadmium 2 plus aqueous plus 2 Ag solid. So here also I can write in the similar way. E cell equal to E cathode minus E anode. 0.799 minus of 0.402 volt. Okay. So how much it will be? 0.799 plus 0.402 volt. That will be 1.201 volt. Okay. Up to now this is clear. Now we have to calculate E cell. So this is the standard cell we have calculated. So E cell if you calculate, then what it will be? Nernst equation, you know, no? Is equal to E naught minus 0.059. This is a 2 electron process, 2. So log of, as I have given here, minus, then what it will be? Cadmium 2 plus and Ag plus whole square. So this is at 25 degrees Celsius, because I have written here 0.059. So E is equal to E naught minus 0.059 by 2 log of. So cadmium 2 plus concentration, how much it is given? Here 0.01. 0.01. Okay. Now Ag plus concentration, this Ag plus concentration, but the Ag plus concentration they did not give. But Cl minus AgCl, so cadmium Cl2, if you consider, then what it will be? Cadmium 2 plus 2 Cl minus, so this is 0.01, this will be 0.01, then this will be 2 into 0.01. The chlorine concentration we know, and other thing Ksp value of AgCl it is given. So Ksp of AgCl, what is? I think I can take some other color. That is Ag plus concentration plus Cl minus concentration. So this value it is given, this value it is given. So Ag plus we can calculate, right? Then we can write here log of 0.01, or instead of Ag, what we can write? Ksp divided by Cl minus concentration whole square. Okay. So this value it is standard, this one it is given 2.01 minus 0.059 by 2 log of 0.01. Ksp value of 1.8 into 10 to the power minus 10. 1.8 into 10 to the power minus 10 divided by Cl minus 2 into 0.101. That square. So if you calculate this one, then you will get to know the cell potential, EMF. Okay. This one it is getting from this equation. So next, this one also you have to calculate from the now. E cell is equal to E naught. Okay. Minus 0.059 by 2 log of Cl minus whole square and cadmium 2 plus. So from this equation. Okay. So this one 0.24 minus 0.059 by 2 log of chlorine minus concentration. What is chlorine? 0.1 whole square. Cadmium, what is the cadmium concentration? 0.01. Oh, this is 0.02 because this 2. Okay. So you can get the EMF value of from here. So now we have to compare this one and this one. So if people can one by one, you can calculate how much it is coming. Can anyone calculate? Okay, if people can do in the this calculation in your room, so I can write how much it will become, so you can back check so it is correct or not. So I think this one, it will be around 0.783 volt. Okay, and next one it will come 0.785 volt. Okay, so if people can check once in your in the room. Okay, you can calculate yourself and check this much is coming or not. So we can go to the next problem. So calculate the standard EMF of the cell for a reaction copper plus Ag plus is going to copper 2 plus and Ag. So standard potential is given. Then calculate. After that, this is one question. Calculate the standard EMF value and then calculate the standard free energy. Okay, so this is quite easy. How you can write? You can write the equation. This one. Copper, what is happening? Copper is going to copper 2 plus, that is oxidation. And Ag2 plus is going to Ag, that is reduction. Okay. How you can, suppose I can construct the cell. Okay, sorry. So cell reaction I can write. How we can present the cell reaction? So copper is going to copper sulfate. Copper 2 plus maybe copper sulfate I can write. Then it is connected to salt bridge. And then silver nitrate. Okay, so silver nitrate going to silver. So this way you can write. Right? Then you can write now it is easy. So how do you can write? E standard cell, that is E naught of Ag plus of Ag minus, because what you can write, this is E right minus E left, that kind of thing, or you can write E cathode minus E anode, because this is the cathode reaction where Ag plus is going to Ag, reduction is happening, and this is the anode reaction, copper is going to copper 2 plus. Okay, so same thing, copper 2 plus copper. So it is given the value Ag plus 0.8 minus 0.34 volt. How much it will be? Oh, 1.1 volt. Okay, this is easy.
No, it is 0.46, no, sir. 0.8 minus
Oh, sorry.
0.34.
Yeah.
0.46, sir.
Correct. It will be 0.46
46.
volt. Yeah. So E cell we got. Now second question is calculate the standard free energy changes of the above cell reaction. What is the free energy equation?
Delta G is equal to minus NEF.
NF del E. Okay. So we can calculate, this is the 2 electron process. So minus 2 NF6500.464. Okay.
Mine is 88.78.
Minus 88.78.
0.78.
Yeah. Yeah. Okay. So this is the answer. Now we can go to the next different problems. Okay, so the question is construct a cell, whatever I have written here, the cell. So that kind of cell we have to construct. Okay, this one, cell reacts. Construct the cell for a reaction, cobalt plus nickel 2 plus. I think this will be superscript. Okay, so which is copper 2 plus nickel. Okay, so calculate the EMF at 98 degrees Celsius. I think it is quite easy. Whatever we have done previously, so same thing. How much it will be? So along with you, I can also people can do sell. So this nickel to this is the sun and this is oxidation. Okay. Sorry. So what will be the cell reaction? Cobalt is going to cobalt 2 plus oxidation, a constant 0.01 molar, and nickel 2 plus 0.1 molar nickel. Okay. Here I want to tell that here you have to, there is small trick is there. Here it is given that calculate its EMF. Okay. But earlier it was there the standard EMF. So for the you just subtracted, this is the standard EMF. But this is not the what is called whatever cell potential used to get from the measurement. So that is not this thing. Okay. So that means here you have to calculate the EMF of the, so not the standard EMF. Okay, it is also easy. Means we have to use the Nernst equation. So here it is given the concentration, so we have to use that one. Okay, so if people can do this thing, I am doing slowly. So this thing, then what will be the E cell? E of what is called right side nickel. So that nickel will be minus E of cobalt. So in the nickel we can write E naught of nickel plus 0.059. This is a 2 electron process. So log of concentration of nickel 2 plus. Okay. This is one. And another one for cobalt we can write E naught of cobalt plus 0.059 by 2 log of cobalt concentration. So E naught of nickel, how much it is? Minus 0.236 plus 0.059 by 2 log of nickel 2 plus concentration, how much? Nickel 2 plus 1 molar. Okay. Minus, this is cobalt. Cobalt, how much it is? 0. So if it is come outside, so minus it is there. So minus it will be plus 0.282. This will be minus 0.059 by 2 log of cobalt concentration 0.1. So now we can calculate what will be.
0.092. 0.092.
0.092. Okay. 0.092 volt. Okay, I am not checking this thing. If people can once check once, I think 0.2. 0.282. Mine is coming different. 0.076.
Yes, sir. 0.0755. Yeah. 0.0755.
Okay. So this is the thing. Means whatever in two question you have to calculate same thing, but you have to reminder this thing. So standard EMF and just EMF value. Okay, so what they are asking, so you just keep in mind. Then it will be easy. Otherwise, means people can calculate the EMF value, but they have asked standard EMF value, so that you have to remind. Okay, now there's another question. So calculate the equilibrium constant for a reaction of Fe2 plus. I think this all will be superscript. Okay, 3 plus 3 plus. So equilibrium constant, that is K equilibrium, we have to calculate. Okay, so how we can calculate? The standard is given. But we can write this equation, equilibrium constant. This is product concentration divided by reactant concentration, right? Where this is the equilibrium constant. Okay. So now we know that what is called. Now it's the cerium constant, standard potential of E cell, it is given cerium, and I think standard potential of Fe3 plus 2 plus, that we know. So for this it is not given, so 0.77 volt. That all people almost know this value. So now what is called, if we write for each equation, Nernst equation for each cell, so E is equal to E standard of cerium 4 plus cerium 3 plus 0.059 by n log of cerium oxidized form by reduced form. For iron, what we can write? Fe3 plus 2 plus 0.059 by n log of Fe3 plus Fe2 plus. Okay, now we know the logarithm theory A, B, that is log of A plus log of B. That things we know. Then if we, what is called, you can see here and here. So if cerium 4 plus is up and Fe3 plus here. Okay, so what you have to do? Can anyone guess? Basically, what we have to do? Fe3 plus the cerium is reducing. and iron is oxidizing. So what we know? E reader minus E ox. So that means from here to here, if this is 1 and this is 2, then you can subtract 1 minus 2. Then it will come this equation. Means E of cerium 4 plus cerium 3 plus minus E of Fe 3 plus Fe2 plus. Okay. That and this one, so 0.059 plus 0.059 then log of cerium 4 plus Fe minus then Fe2 plus it will up cerium 3 plus Fe 3 plus below. Okay. Then here you can see that this equilibrium Fe3 plus is up. So that means this part you have to opposite. That means 1 by K equilibrium it will be. Whatever this way. So this value you know, this value you know, and this N is equal to how much? N is equal to 1. So this also know. And E cell. So E cell calculate the equilibrium constant. So E cell you can calculate from here. But in this reaction, E cell they did not given.
Even they have not given E naught of Fe2 plus, Fe3 plus bar Fe2 plus.
Mm-hmm.
Data is incomplete, right? Is it correct, sir?
Fe3 plus, can you repeat once?
Yeah. 0.77, that is not a given, right? That is a given data.
Oh, okay,
Yes.
okay. No, actually, some cases it is called if means some standard value like Fe3 plus Fe2 plus. So sometimes in the question they will not give. Means it is called people know for this they may not be give sometimes. Okay. But the things is E cell, it is E not cell, so that things it is not given. Okay, but means I think here is they should give the E not cell. Okay. So then we can calculate from here what is the K equilibrium. Okay. But this is the procedure how we can calculate the Fe what is called equilibrium constant. Okay, so I can check this one once again. And next week I can discuss these things, but I think they should give this essay.
Yeah, if they given that, I think we got it. How to solve? If they given the data, then we can put it and we will get it.
Yeah.
That is not a problem. No need. I think we can do that. Not a problem.
Yeah.
Only thing given data are missing. Data are missing.
Yeah. Okay, so this way you can do this kind of problem, and I think next problem we can see. Okay. So what is the equilibrium concentration of Fe2 plus reached when a piece of iron is dipped in a 0.1 molar zinc 2 plus solution? Okay. So yeah, here like they have given the potential. So means basically, I think this is the electrolytic cell kind of thing. So here you have the solution of 0.1 molar zinc, what is called iron, and in that you are dip a piece of iron, and on the other hand, zinc 2 plus solution where you are putting the zinc. Then they are telling the how what is when it is reached to the equilibrium. So what is the concentration of Fe2 plus? How you can calculate this thing? Can anyone tell? We can write the cell first, then it will be easy. What is the cell reaction is happening? One is Fe is going to Fe2. So that is the oxidation. And what is the other thing? Zinc 2 plus is going to zinc. That is the reduction. So E standard potential is cell. What you can write? E
I
naught
think
of zinc, because this
a
is the
piece
right.
of zinc, piece of rod, zinc rod is dipped in 0.1 molar, right? In a piece of
Sorry.
iron, in a piece of zinc rod is dipped in 0.1 molar zinc sulfate solution, right?
Iron rod.
Iron in zinc.
No, actually you have to think here. What is called? We learn this electrochemical reduction voltage, no? There it is to one table where SH is there. Then for lithium it is minus 3.1 volt. For zinc it is minus 0.7776 volt, like that. So means whoever is more negative, it can be easily oxidized. Means lithium is, it can easily can we go to lithium plus. So like that means here you can see the standard potential of zinc is minus 0.76 volt, and for iron minus 0.32 volt. Means zinc can easily what is called reduce the other person. A piece of iron is dipped in the 0.1 molar zinc solution.
No, that should be zinc, sir. When a piece of zinc is dipped in 0.1 molar solution of zinc Zn2 plus ions. So in the place of iron, there should be zinc.
Okay, now got it. Yeah. So you're telling here is the zinc sulfate, and here is the iron sulfate, and here the iron rod, and here is the zinc rod. Is it?
Yes, that's correct, sir.
Yeah, and it is connected to the salt bridge. Yeah, I think this will be zinc. Yeah, now I think it is okay. So yeah, that is correct, I think. Thank you. So what we can okay, now what we can write this is the R and this is left. So E naught minus E of Fe. So these things it is given minus 0.76 minus of 0.32 volt. Minus 0.76 plus 0.32 volt. Okay. Then how much it will be?
0.44. Yes.
Okay.
0.44.
So this thing is there. So E cell is given. Now we have to calculate equilibrium concentration of Fe3 plus. So at equilibrium concentration means that is called in for this reaction, what we can write equilibrium concentration? Equilibrium constant, that what I can write? Fe3 plus Fe is going to Fe2 plus. So Fe2 plus concentration divided by zinc 2 plus concentration. Now another equation, so that means in zinc concentration it is given. So equilibrium constant if we calculate, then we can get the concentration of Fe2 plus. Okay. So what we will
Hello, sir. Zinc is anode here. Zinc is anode. Iron is cathode. So it should be like minus 0.32 minus of minus 0.76. Because the electrode potential of zinc is minus 0.76. This is the least one. It should be, it is an anode. And iron is the
So
cathode here.
okay, this is 0.036 means it can easily oxidize.
Yeah. That is an anode. So
Yes.
regarding cell representation, zinc should be on the left side and iron should be on the right side.
Yeah.
So the
That's true.
answer E naught of the cell becomes 0.44 volt, not minus 0.44 volt. Minus
Got
of
it. Got it.
0.32 minus of 0.76. Yes.
Zinc 2 plus, what is called then Fe 2 plus 2 Fe. Yeah, so this is minus 0.23 means it can go to reduction. Yeah, that is correct.
So then
Okay.
it becomes plus 0.44.
So this will be, we can cut it, minus 0.32 minus of 0.76. Then it will be plus 44. Okay. So now E cell, what you can write? E cell, that is 0.059 divided by, as it is a 2 electron process, so we can write 2 log of K equilibrium. So now we know what is called E cell, we know 0.44 volt, 0.059 divided by 2 log of equilibrium. So from here you can calculate the equilibrium constant. Okay, and then we can put this equilibrium constant here, and we can calculate the concentration of Fe3. So this is, I think, 0.1 volt. So that things we can calculate, right? Okay, so next question you can go. I think there is any other question. Yeah, I think this may be the last, or I don't know. So calculate the E naught and K for the following conversion in acidic aqueous medium. There is the manganese 2 is going to manganese 2 plus MnO4 minus. Okay, so E naught is given. Sorry, manganese O2 to manganese 2 plus, it is given. And manganese O4 minus to manganese 2 plus, it is given. Okay, so then okay, what is the cell potential E naught? Okay, so what I can write these two equation in the anode. Which one will be the anode? Manganese O2, that is solid plus water molecule, MnO4 minus plus what I can write H plus 3 electron. So if I balance this thing, this will be 4. So it is given 1.69. Okay. So this is the reduction potential. In the cathode, what it will be? Manganese O2 plus 4H plus 2 electron. Manganese 2 plus 2H2. E naught 1.23 volt. So these things I have written. Okay. Now if I combine these two, then what we will get? So this 2H2O here, 2H2O, it will be cut out. So 4H plus, here 4H plus, that will be cut out. Then we have manganese 2 plus, MnO4 minus, whatever it is here, so that thing we will get. Manganese O2, that will be MnO4 minus plus Mn2 plus. So that means we have to combine these two equation. So that means E cell, that is, what is the anode? This is the anode. E cathode minus E anode. I think, right? E naught, as it is standard state. So E cathode 1.23.
So
minus,
the one having the least value is the anode. It should be reverse. The first combination is the anode and second combination is the cathode. But here, so 1.23 is the least value compared to 1.692. So the combination having 1.23 is the anode and 1.692 is the cathode. So we have to interchange anode and cathode, sir.
no. Let me think once. These things you are telling, this is the highest one, this will be the cathode.
Cathode.
Okay.
The first combination is the least one. It should be anode. So then the E naught of the cell is E cathode minus E anode. 1.692 minus 1.23. Not 1.23 minus 1.692. Correct, no, sir?
Yeah, that is whatever you are telling, that is correct. But let me check. This is how much oxidation state. This is plus minus 4 plus 7, I think. X minus 8 is equal to minus 1. Plus 7. Here how much it is? Plus 4. Yeah, this is the reduction value. And this is plus 4. And this is plus 2. Yeah, this is also reduction potential. Now, actually, I am thinking that sometimes they used to give the oxidation potential. Yeah, it is correct. Then I have to change this one. This one.
That is cathode. First one is cathode. Second one is anode.
Cathode. And this is anode. Yeah. So that means I have to change this one. Cathode minus anode means.
So 1.692 minus 1.23 and it comes around 0.462.
1. This is cathode 1.692 minus 1.23 volt.
0.462.
Okay. Yeah, now it is correct. Okay, so now E cell is calculate. Now we have to calculate the K value. Is it? K, so now what is called K value E cell. I think last whatever we have done. So this equation you have to put and then we can calculate. This is the equation. Okay. 0.059 by 2. So here what is the number of electron, how much? So there is plus 2. This is 3. 4 electron plus 4. This is 2 plus, and this is plus 7. Plus 7 plus 9, and this 4. So this is 6. See, n is equal to 6. 6 or 5? Here is minus 1 is there, yeah. 6 electron. So n is equal to 6. Because here is plus 4 oxidation state. And here manganese is plus 7 oxidation state. And here is plus 2 oxidation state. Okay. So, and 1 minus is there. So we have to balance the charge. So this is 6 electron process. So n is equal to 6. That means 0.059 by 6 log of equilibrium. E shape. Okay. So that things we have to do. I think this is the last one. So calculate the potential of a solution at equilibrium potential. No, equivalence point. Sorry, equivalence point is the titration of 25 ml of 0.1 normal ferrous sulfate solution with 0.1 normal of chromate solution. The pH of the solution may be supposed buffer to pH 1. So potential, calculate the potential of the solution. So basically this is the titration, potentiometric titration, where you are doing the what is called iron sulfate is there. Basically oxidation reduction potentiometric titration. And chromate you are taken in the burette, and in the conical flux Fe2 plus solution is there, and you are what is called doing Fe2 plus oxidation reaction, so which is going to Fe3 plus, I think. Then what is the potential of this cell? Okay. Okay, I think here what is some value is not given. The standard potential is required. Standard potential of chromate Fe3 plus Fe2 plus, that is okay. That is 0.77 volt. And standard potential of chromate Cr2O7 2 minus chromium 3 plus, it is to go. That is how much? 1.36 volt, I think. Okay, these two value they'll give actually. I think I mistake that thing. I did not took that value. Yeah. So basically, you have to write the equation. I think these things is to do in the BSc time. The what is called this potentiometric titration with the chromate salt. So basically, Fe2 plus in Cr2O7 2 minus. So is to do in the acidic solution. So H plus will be there, and Fe3 plus, which is go, and chromium is to go chromium 3 plus and H2. Okay. So this is the reaction. Okay. Now we have to balance this reaction. I think chromium 2 plus, this is 3 plus, this is Fe2 plus. Then okay, what is the, people can also balance this equation. Chromium 2 plus is 2, so here chromium 2, here I can write 2. So it's 2, oxygen 7, here 7, then here H2O, that is also 7. So H plus 14 it will be, and this will be 6 plus 6, 6. I think it is balanced. Yeah. 7H2O, these things is there. Okay. So this equation, I think this equation is quite tricky to balance. I think these things also, I think they will give in the question. Okay. And these two also it will give in the question. Then we can calculate all other things. It is quite easy. Okay. So means whatever you have to do, then you have to apply the Nernst equation. Nernst equation for these two. Then you have to combine that okay, what is called equation, and you can get this thing. So basically, for iron, what you can write equilibrium, that is E naught minus 0.059 log of Fe2 plus by Fe3 plus. So this is one equation. Other equation is equilibrium. So at 6 molecule of what is called chromate iron, it is going. So 6 into equilibrium of chromate. Okay, minus 0.059 log of chromium 3 plus. This is 2 square it will be. And below chromium 207 2 minus and H plus. That will be, it is 14. So power will be 14. Okay, so these two equation you will get. So from there you have to subtract these two. Okay, then you will get the potential, equilibrium potential of the cell. So you know the standard potential and the concentration also it is given. So then you can get the potential. Okay. I think, yeah, that's all. So, other thing is, I think this potential thing that reduction and oxidation, that things we have to a little bit remember, because I am also doing the mistake. So when will people do in the exam or something, so that thing please remember. Okay, so that's all. Any other question is there?
Sir, I have one or two doubts, sir. Sir, in assignment 3, in question number 2, actually the answer what we got is 1.2184, but you have given only up to second decimal, that is 1.21. For that, the score is given for me is 0, sir. If we write up to fourth decimal also, it is taken as wrong answer.
Tell me once
Can you
again.
see question number 2 in assignment 3? Can you see right now, sir? Can you see the question and also the answer?
Okay, just
assignment 3, sir. Assignment 3, question number 2.
Okay, assignment 3. Okay,
yeah.
Assignment 3.
Question number 2.
Okay.
So the actual answer for this problem is 1.2184 volt.
Which one? Okay.
What is the EMF of the cell? Zinc and copper combination is given, sir.
Okay, today or today's assignment
Previous
4.
one, previous question, assignment 3, sir. Previous week question.
Okay, let me check. I forgot because I did not give the.
Not the problem solving session, sir. Questions, assignment questions.
Okay, actually, I have discussed only the old, what is called, previous year assignment. The present assignment, I did not have discussed.
No, sir, my question is,
Mm-hmm.
if you're, just listen, sir. The
Mm-hmm.
answer for the question is 1 point. Just you can make a note of this, sir. Answer is,
Okay.
what we are getting is 1.2184.
Just
This
a
is the
minute.
correct answer. Here we have
One
given the
point.
answer up to fourth decimal.
You can repeat once again.
2184.
1.2184. Okay.
Yes, sir.
And
For
here,
this, the score I got is 0. And
okay.
later on, the
Mm-hmm.
given expected answer is 1.21. What we have to do for this? They are given up to the second decimal and they have
Okay.
considered our answer is wrong.
Okay, okay. I think you can mail them, but because they did not mention the how much decimal you have to give.
Yeah.
Is
To whom we
they
need to mail, sir?
sorry?
It should be mailed to whom?
In the PMRF coordinator, you can sorry, not NPTL coordinator. Means what is called someone is there, no NPTL
If you write the
support.
answer for the second and third decimals, for most of the
Mhm.
problem, we are not getting the correct, we are not getting the correct score.
Okay, okay. I think
Mm.
it's better to means send a NPTL support mail, or in the course also means they have given the what is
Sir,
called
I
contact mail, no?
think the NPTL, the course coordinator will not do anything. Just inform to your sir. So they have
Okay.
to, they have to inform NPTL coordinator to change it.
Okay. Actually,
Just to
I
give
don't.
information to your sir once. Later
Okay,
we'll see,
that
sir.
okay, okay. But I think it's safer side. You can send a mail to NPTL coordinator, or what is called course support, whatever, where you can contact. Okay, so them you can contact and you can put a mail them. I think it is correct only. Maybe means whatever their system they have said. So if only that much is correct, then it is taking as a correct answer, I think. So means you can send a mail, so I think they'll rectify that thing.
Okay, sir. And one more thing.
Mhm.
So you have given link for the assignment solutions, but it is
Mhm.
not opening at all, sir.
Okay, I
The
have
link
changed the.
given for the assignment solution is not opening right now, even for all the 3 assignments.
Okay, you are not able to open the Google Drive
Yeah,
link.
yes, sir. Not able to open. It is not at
Okay,
all
last
opening.
last what is called last week
For all the
things
3,
also.
week 1, week 2, week 3, for all the 3,
Mhm.
it is not opening.
But I have given the access. I have changed the things.
Hmm.
I think last time means they used to ask for the what is called access. So after that, I have changed that thing. So means it can be editable to anyone. So that things I can.
Please check it once, sir. We are not able to open the link.
Okay, just a minute. I can and just a minute. I can check once. Okay, because I have given the access. Uh, Now I can once I can share now. Quite slow.
Our colleague also tried, Anil. Anil is also tried and is also not able to open.
Oh, okay, okay. I think Anil also sent me mail. I
Yeah,
forgot to
yeah.
reply him.
Hmm.
Mm, okay, I think Anil is there.
Anil,
Yes,
Anil.
sir.
You can also
Sir.
speak.
PDF file, sir. The PDF file, which is given which is it is not the problem solving. We are telling the assignment PDF file.
Yeah,
It is
that's what I'm telling also.
it is like the link is like files C drive something is there and a .pdf. So even if we copy it and open in new browser, it is showing the file is not opening.
Okay. Okay, can you check? Now I have shared the
The
link.
course coordinator is doing.
Okay, so Anil, you can check once. I have sent you the mail with link. So
Okay.
you just check once now only. Then I can check. Otherwise, I can modify the things because I can see that
Even
it is.
so even Ritambara Saha also they are telling assignment solution link is not opening, and that is the thing like that C drive PDF link is not opening.